Hello all. So again we are going to solve a problem which is related to the analysis of the AC circuit and the circuit which is given here. In this circuit we have to determine the total impedance which this source can see from these points. Similarly, we have to find the total current, calculate the value of the voltages which are dropped across this resistance and this capacitor as well, and at the end we have to find the power and then power factor. Okay, so let us start it from part A. So in part A of our question here, what we have to do, we have to find the total impedance. Okay, so Z of t, as I have told you earlier that to find the value of Z of t, what we have to do, we have to look for all the real values here, and all the real values are possessed by the resistors here. Okay, so as we have just one resistor, what we have to do, we have to write the value of resistor. After it, what we have to see, we have to look for the reactive elements which are present in our circuit. Okay, so there is only one reactive element, that is the capacitor. Okay, so therefore for the capacitor, what we have to do, for any capacitor I have to write the negative sign with the J, and after it write the capacitive reactance. Okay, so here after putting the values here, we will get the total impedance here, but there is an issue here, and that is we are not given the value of X of C, but we are given the value of capacitance. Okay, so this is here we have this 0.2 microfarad. Okay, but we don't know the value of X of C. So in order to find the value of X of C, what we have to do, we have to see that this is equal to 1 over omega C. Okay, C is already known here, but what is the value of omega? Omega is again unknown. Okay, so in order to find the omega, what we have to see, we have to look for the frequency which the source has. So we are given here the frequency, and the frequency here is 1 kilohertz. So the frequency here is 1 kilohertz. Okay, so from it I can very easily find the value of the omega. So omega is the radiant frequency, and that is 2 pi f. Okay, now putting their values here, what I will get, omega is 2 pi and 10 raised to the power 3. Okay, so that is 2 pi into 10 raised to the power 3. Now taking it and putting it into here, okay, what I will get, I will get the value of Xc is 1 over 2 pi into 10 raised to the power 3, and the value of capacitance is already known, that is multiplied by 0.2, and micro is 10 raised to the power minus 6. Okay, now simplifying it, what I will get, X of C will be equal to the 1 over 2 pi, this 10 raised to the power 3 with this 10 raised to the power minus 6 will be 10 raised to the power minus 3. So 2 pi into 0.2 into 10 raised to the power minus 3, and similarly it will be here 2 multiplied by 0.2 is 0.4 pi into 10 raised to the power minus 3. Okay, or simplifying it again, I will get, moving it to the upper side or to the numerator here, what I will get, 10 raised to the power 3 divided by 0.4 pi. Okay, now in order to simplify it some more, let me go to the calculator. So in calculator here, let me write the values. So that would be, sorry, 1000 divided by 0.4 multiplied by pi, so this is pi. Okay, so what I will get here, this will be 795.77, which is 795.8. okay, so 795.8 ohm. Okay, so that is the value of X of C. Now as we have this equation, and I called it equation A, putting this 795.8 into this one, or let me again use the same convention. Okay, putting it here, what I will get? I will get Z of T is equal to, now the value of resistance is 2.2 kilo ohm, writing it here 2.2 kilo, and minus J, X of C is 795.8. Okay, so that is basically in ohm, and this is in rectangular form. Okay, let me convert it into the polar form. So that Z of T is, so this is 2.2 K, which is 2200. Okay, so now let me use it. 2200 minus 795.8 with the iota. Okay, so this one here, or okay, so this one is here. So in order to convert it into the polar form, what we have to do, let me press here 2 and this 3. Now what I will get here, 2339.5, 2339.5 is the amplitude, and what is the value of angle here? Angle is minus 19.9. okay, so angle is minus 19.9 degrees, and that is in ohm. Let me write ohm here, and this is the value of the impedance in polar form. So this is the answer of part A of my question. Okay, now similarly, in order to find the value of current here, let me use it here. So now I can see that the value of current is basically E divided by Z of T. Okay, do I know the value of E? Yes, I know the value of E, but that is basically the peak value of the sine omega t. So that's why in order to convert it into the polar form, I should have the RMS value. Okay, so in order to convert the peak value into the RMS value, what I have to do, I have to divide it over the square root of 2, and dividing it over the value which is now Z of T. So as this is the division, so convenient way of using this will be, okay, so the angle with it is basically 0 degree here. So as I have previously stated, the convenient form of the quantities which I have here are the polar forms for the division. Okay, so now I am using this form of my impedance here, so that would be 2339.5, and that is minus 19.9 degrees. Okay, now what I will get, 20 divided by square root of 2 divided by the square root of 2, I will get here 14.14. so 14.14 divided by this 2339.5. okay, and that is 0 degrees. This will go upward, and here it will get 19.19 degrees. okay, simplifying it some more, what I will get, this 14.14 divided by 2339.5, 2339.5. okay, so that is almost 6 milliamps. okay, as this is 10 to the power minus 3, so 6 milliamps, and the angle it has is 19.9 degrees. okay, and that is the current, which is part 2 of my question. So 6 amps is the value of the current. Now for part C of this question, I have to find out the voltage drop across the resistor and similarly across the capacitor as well. So now here in part C, I have to find out the value of VR. So as resistor and capacitors are in series, so the same amount of current is flowing through both of them. Therefore, total I multiplied by the value of R. Similarly, the value of C is current multiplied by x of C, okay, but with minus j x of C. So now here the current is already known, and that is 6 milliamps, which is 10 to the power minus 3, and the angle it has is 19.9 degrees, okay, and the value of the impedance was basically 2.2 into 10 to the power 3, which was basically the resistor. So these two will cancel out, and what I will get here, 6 multiplied by 2.2 is how much? 6 multiplied by 2.2 is 13.2, okay. So 13.2 volts, and the angle it has is, phase angle it has is 19.9 degrees. This is V of R. Similarly, in order to find the value of V of C, there I have this 6 into 10 to the power minus 3, and the angle it has is again 19.9 degrees multiplied by Jx of C. What is the value of x of C? That is already known, and that is 795.8. So 795.8, and the availability of this minus j will make it minus 90 degree, which I have previously illustrated in my videos, that why I use this minus 90 degrees or 90 degree whenever I will have plus j or minus j with the imaginary quantities, okay. So it is very easy for you to comprehend here that why I have used this minus 90 degree here. So now multiplying them together, what I will get, so 795, and this is divided by 1000. So let me move here. So here 795.8 multiplied by 6. So this is this one, and divided by 1000 will give me 4.77, which is 4.8 volts, okay. And what is the angle? So 19.9 degrees, and that is minus 90 degrees. So how much would it be? So 4.8, and the angle it will have is 90 minus 19.9, 70.1. So that is, as the larger value here, it has the negative sign, so minus 70.1 degrees. So that is also in volts, and this is what? This is the voltage across the capacitor here, okay. You can also verify it to see that whether all the voltages available in my circuit obey the KVL or not by using the formula, and that would be E equal to VR plus V of C, and you will see that the phasor sum of VR VC will eventually give you the value of E, and that value will be 20 divided by square root of 2, okay. So you can very easily find them out by using the procedure which I have previously shown you, okay. That's it for this part of question. So in part D of in our question, what I have to do, I have to find the value of the power and f of p, which is the power factor. So let me first find the power factor, because that is the important one. So power factor, as I have previously told you, that is R divided by Z of t, or is also equal to the cos of theta, where theta is the angle between the total voltage and the current as well, okay. So let me use this one, okay. Let me use this one here. So in using this one here, so cos of theta is, what is the theta? So the current here we have found out, in the current the angle is 19.9, where the angle with the voltage, phase angle with the voltage is 0 degrees. So, it would be cos of 19.9 degrees. So, it will be cos of 19.9 degrees, and here I will get 0.94, which is very good angle. 0.94, yes, 0.94. And as we can see that this is the capacitive circuit where current always leads. Therefore, I have told you earlier that we have to relate it with the lagging or leading characteristics of the current. So, as the current always leads in the RC circuit, therefore, this is 0.94 leading. Okay, you can also see it from this formula that it will also give you this value. Okay, so now after it, what I have to do, I have to find the power. So, the power here is I multiplied by E, and that would be multiplied with the power factor. So, the power factor is cos of theta. So, now rearranging it, and I will I multiplied by E multiplied by power factor. Okay. Now, putting their values, what I will get? So, I have is 6 milliamps with the angle 10 to power minus 3 with the angle of 19.9 degrees, and the value of the voltage was how much? That was 14.14, okay, with the angle of 0 degrees, and this was 0.94. Okay. So, now the power I will have is multiplying them together, 6 multiplied by 14.14 and multiplied by 0.94, that would be 79.74 into 10 to the power minus 3 watts, 79.74 watts. Okay. So, that is the power, or we can call it the real power, and from it we have obtained the values which were needed. So, that is the end of our question, in which we have found out all the required quantities in our RC circuit, and I hope all the steps which have been covered in this question will be understandable and will be easier for you to grasp the concept. Thank you so much, and I will see you with some more examples in our upcoming videos.